now we have the last kind of compound probability, which includes the word "and" in the problem. So the first thing we always want to find when we're talking about the P word, the probability, is the total. So count them up. Total should be 9. So we're going to use that number, and let's say that you reach your hand in for 2 tries, okay? And the first marble you pick is an orange, and let's say with replacement. So you reach your hand in, you pick an orange, and then you throw it back in. So you replace the orange marble after you pick it out for the first pick. So first pick, we know that the total goes on the bottom, so 9. And then we know that there's going to be 1, 2, 3, 4 orange on the top. And when you're doing AND probability, you will always multiply the 2 picks together. So your first pick, you have a 4 out of 9 chance of picking an orange. You throw the orange back in, so the total goes back to what it was. You might have taken an orange marble out for the first pick, but then you threw back in for the second pick. So whenever you see with replacement, the 2 totals, or however many picks, should always be the same. So we got a 9 here, and then you throw that marble back in. That means that there's still going to be 9 in that box. That also means that that first orange that you picked here, well, you threw it back in. So that means that there's still going to be 4 orange marbles in there for the second pick. So it should be 4/9 times 4/9, and you get 16 out of 81. So there's a 16 out of 81 probability that you pick an orange first, replace it, and then pick an orange second. Now this time I'll keep it the same scenario, orange and then orange, but I am changing it so that now it is without replacement. So you take that first orange out, you do not throw it back in, and then you want to find the probability of picking an orange the second time when you do not replace it. So the first pick, it's going to be 4 orange marbles out of a total of 9, just like it was before. Now you keep that orange marble out. I'm going to actually erase it. So change to eraser. Let's say I get this one at the top, gone. So if you go back to count, 1, 2, 3, 4, 5, 6, 7, 8. Now the total went down 1 because you did not put that first marble back in. Okay, now count up the orange. Well, I only see 3 there. Okay, so the total of the orange in there went down by 1, 2 because you didn't put the first orange marble back in. You left it out. So that's going to affect how many orange are in there, and it's going to affect how many total marbles are in there, as you can see in the drawing. Now, you're still going to multiply whenever we have AND probability. You multiply the 2 instances together, and you get 12 out of 72. I'm going to simplify that by dividing out of 4, and I get 3 on the top, and I get 18 on the bottom. I can actually simplify that again by dividing out of 3, which would leave me with 1/6. So I have a 1 out of 6 probability of picking an orange, not replacing it, and then picking an orange again. So the difference is the total goes down 1, and also since it's the same color we're talking about, the amount of orange goes down 1, 2 from first pick to second pick. Now I want to do the problem still without replacement, but I'm doing an orange for the first pick and a blue for the second. So let's look at the total. Notice how I threw that orange marble back in there, so the total is going to be 9 again. And there's going to be 4 orange marbles multiplied. Now you do not replace that first pick. So what's going to happen to the total? Well, if I take out that orange again, I'm going to use my little eraser. Notice how there's 1 less. So the total goes down to 8 because you don't throw that first marble back in. Now, since you took out an orange for the first pick, that's not going to affect how many blue are in there. All right, it started at 3 blue, it stays at 3 blue because that first marble was an orange. That doesn't affect the amount of blue in there. So 1, 2, 3, I'm going to use 3 for the top for that. Okay, the only thing that happened with different colors is that the total goes down. So you started with 4 orange out of 9 total. You do not replace it. So now there's 8 in there and 3 of them are blue. So your probability should be This one just happens to be the same one as before, so I'm going to bring it down, simplify by dividing out a 12. I get 1 out of 6 chance of picking an orange, not replacing it, and then picking a blue. Let's try some. Notice how I threw that little orange marble back in there for this problem? I want you to find the probability with replacement, picking 3 blues in a row with replacement. Pause it and try it now. You should end up with 1 over 27. If you didn't, you probably just forgot to simplify. Okay, so 3 blues in a row with replacement. So these totals, notice how they're all 9. You're throwing them back in. First pick, second pick, third pick. Goes back to 9 each time. Also, the blues, even though you're picking blue, you're throwing it back in each time. So that goes back to 3. All right, and then you just times the numerators and the denominators. You end up with 27 over 729. Divide out, your greatest common factor. You end up with 1 over 27. I just went for the big shot. I divided out that 27. I usually start with that and then just kind of go down if that doesn't work with these bigger numbers. I just lucked out. So, all right, let's try another one. This time you're going to find the probability of picking 3 blues in a row without replacement. Ready? Go. You should end up with 1 over 84. So since you are not replacing, the first pick, you start out with 3 that are blue over 9 total. And then your second pick, you're going to go 1 less. So you have 9 to start with, but then you don't throw it back in, so your total gets 1 less. Also, your blue, the same color, gets 1 less because that first marble was blue. That means that there's only 2 blue left. And then on your third pick, you're only left with 1 blue marble left and 7 total. It goes down each time for the blues and for the total. You get 6 over 504, and then you just simplify it by dividing out that 6 for both of them, and you get 1 over 84. Let's try maybe 2 more. This time, try to find the probability of picking a red and then an orange without replacement. Ready? Go. You should have ended up with 1 over 9 for your final answer after you simplify. Now remember, without replacement. So you start out with 9 on the first pick. And then there's 2, of course, that are red. And then you don't put it back in. You end up with 1 less in the total. So 8 for the total for the second pick. All right, but there's still going to be 4 orange in there because if the first marble was a red, well, that means that there's still the original number of 4 orange marbles in there. You multiply and you simplify, you get 1 over 9. This time, try to find the probability of picking a red and then a blue with replacement. Ready, go. This one, you should end up with 2 over 27 for your final answer. Remember, when it is with replacement, the total stays the same each time because you're taking that first pick out, throwing it back in, so the total goes back to 9. Now we're talking about red, so there's 2 red in there, and then there's 3 blue, so that's where I got those numbers. 6 over 81, I just divided out a 3 for both of them, and that's how I got my simplified answer. Thank you so much for watching this longer video about and compound probability. I hope it was helpful. Please leave any suggestions or questions in the comments below. Thank you. Bye.